This video talks through the main questions you can get asked linked to sectors. Now, a sector is just a fraction of a full circle. So this 5 is effectively the radius of the circle from which it comes from. Now, if you're asked to find the area of this sector, then it requires quite a simple calculation. Now, if it was a full circle, the area would equal pi times radius squared. However, because it's not a full circle, we have to think, right, so what fraction of a circle is this? Well, a full circle is 360 degrees, so therefore this sector is 40 out of 360. So we do 40 over 360 and times that by pi times 5 squared. And on the calculator, you'll get 25 pi over 9 in terms of pi. So that's the area of the sector. Again, what fraction of a full circle is it? Then times that by the area as if it was a full circle. So that's the area of the sector. Now for the arc length, it means that curved distance there. Now again, if it was a full circle, the full distance around is given by 2 times pi times r, i.e. the circumference. So you'd work out 2 times pi times r. However, again, it's a fraction of a circle. So it's 40 out of 360, lots of the full circumference. And again, in terms of pi, this works out as 10 pi over 9. The perimeter is then the curved part plus the 2 straight edges. Well, again, since this comes from a circle, both these edges here must equal 5 centimetres. So the perimeter is 10 pi over 9 plus 5, i.e. plus 10. Again, left purely in terms of pi. Now for the final part, I want the area of the segment. Now the segment is the following part of the shape. If I imagine a dotted line across here, or a faint line across there, then this here is the segment. So to work out the area shaded, I need the full sector, and I must subtract away the area of that triangle. Now then, there's a quick way to find the area of a triangle if you know the 2 sides and the angle contained within them. And the area of a triangle, and this formula is given in the exam, is given by a half times by the 2 sides, in which case 5 times 5, times by sine of the angle. More generally, it's given by a half a b sine x. Again, if you know 2 sides and the angle contained within the 2 sides, that's a general formula for the area of a triangle. So I must do the following. Area of the segment equals the sector area, which was 25 pi over 9. Take away this calculation here, i.e. a half, lots of 25, that's 5 times 5, sine of 40. And if we put that into a calculator, the area becomes 0.69 to 2 SF. So sectors, we have the area and the arc length, and these are fractions of the full circle formulae. We have a perimeter, which is the arc plus the 2 straight edges, and the segment, which is the entire sector, take away the triangle part contained within it. And again, the triangle, we have this half AB sine x formula, where A and B are the 2 sides, and x is the angle contained within the 2 sides.